Hey, OChemsters, this is Mrs. Vanderwally bringing you your notes today using the video. I kind of like this way as a change, especially if I'm absent. You can still get the notes. You can still, get all the information. You can pause if you need to catch up talking too fast, and you can take your time. You can listen to me more than once if you ever miss my voice. So today we're going to talk about Chapter 10, carboxylic acids and esters. Carboxylic acid is probably one of the most important organic compound classification functional groups. They've been around for a very, very long time. They've been known about for a very long time. I think it's kind of interesting because a lot of the naming, the original namings came from the carboxylic acids that we can look at and say, oh, I recognize that's the root for 3 carbons. That's the root for 4 carbons. So it's kind of interesting to see where some of that stuff came from. So let's see what our intro says. Says the taste of vinegar, the sting of fire ants, the rancid smell of butter, the relief derived from aspirin are all due to compounds that belong to the most important family of organic acids, the carboxylic acids. The resilience of polyester, nylon fabrics, the softness of silk, the strength of cellulose, our own cell membranes are all due to the erosion of carboxylic acids known as esters. We'll deal with them a little bit later. So let's just start off the functional group that we're talking about, the carboxylic acids. We have 2 sections. You have the carboxyl group we talked about with aldehyde ketones, and then the hydroxyl group, of course, is your alcohol. So how would I show this? I would show C double bond O, OH, and here is where all the other carbons come from. And so this is where we will link more. This is always at the end of the molecule, C double bond O, OH. And as you see, probably is foreshadowing from like yesterday and from the alcohols, carboxylic acids take priority in naming. It will always be your number 1 carbon. So we will always start here and then move along, 3, 4, whatever. We can also show R is any carbon group and then COOH. If you ever see 2 O's next to each other, it's what we're showing you here with double bond O and then a single OH. You might see it as this, RCO2H, or you might use not line notation, and here's your double bond O and O, and I prefer to have the OH still written out. Some groups don't, they'll just leave the H off the O because they leave the H off of everything. I prefer to see the H there just for clarification. Those are all different ways of showing you carboxylic acids. So in this chapter, we will describe the structures, properties, and the basic reactions of carboxylic acids. Today, I'm only going to talk about the nomenclature. So hang on a second. So it says, because of their abundance in nature, carboxylic acids are among the earliest classes of compounds by organic chemists. Many of the common names are derived from Latin or Greek roots. Most of them are actually Latin. And the IUPAC, thank goodness, replaced the final E in the names of the corresponding alkanes and added oic acid. I am very happy for the IUPAC because to me, these common names, original names, can be pretty confusing and hard to pronounce, too, for that matter. If you look at the formula, we only have 1 carbon here. And so we would notice methanoic acid. So notice what it says, you drop the final E, so what was originally methane becomes methanoic acid. Originally, they were named as formic acids. You might recognize the FORN as meaning formaldehyde. We talked about that as your 1 carbon aldehyde. So formaldehyde, formic acid, those all have 1 carbon, and it was originally from the word ant, which is the Latin word right here, and didn't know that. But anyway, if you've ever been stung by fire ants down south, you see those big hills, those itty bitty ants, stay away from those. They pack a huge punch. Ouch. So, yeah, that's where it came from, but today we have methanoic acid. The next one is what came from vinegar. The Latin word for vinegar is acetum, and that's where they came up with acetic acid. Again, it has 2 carbons, and today we call it ethanoic acid. 3 carbons. This is what I think is interesting. So, obviously, carbonic acid, or at least something with perhaps soured milk, because when you get lactose in your milk, become lactic acid. So my guess is that the first cream of the milk, the Greeks called protos. And so that's where propanoic acid came from. And, or excuse me, propionic acid came from, and that's where we get propanoic acid. So that the original prop is from the Greek actual word that meant, you know, this clear acid that came from the cream or the first fat of the milk. And then the last one on this page is another Latin word that means butter. So butyric acid became butanoic acid. And again, it came from the original 4 carbons that is found in butter. So to the page. And on this page is where we find some of these Latin words that honestly they must have changed over since I organic, because I've never heard some of what we call common names ever been used before. So this 5-carbon acetic, or excuse me, 5-carbon carboxylic acid came from the Latin word strong, like, you know, the valor of somebody, I guess, the strength. So valeric acid, I've never heard before, but I have heard of petroleic acid. And then we have, I think this one's interesting. So the Latin word for gout is caper. So if you've ever heard of the astrological sign Capricorn, that's what it came from. It's gout. I don't know if you knew that. So the common name is caproic acid, but we have it as hexanoic acid. It's a little later on too. This next one is another one I have never heard of. So it could be from the oleander, which is, you know, maybe from this word here. I don't really know. Oleander is a pretty flower off of a shrub. But we have enanthic acid as its common name. Again, I've never heard of, so it can't be all that common. And we call it hexanoic acid. Here we see these goats again, all right? So apparently goats have more than one acid found in them. They had to come up with a different name for 8 carbons. So up here it says it's caproic acid, down here acrylic acid. I'm really glad, I don't know about you, we have hexanoic and octanoic. I can think about that and relate that a whole lot better. Number 9 is this came from the Greek for the word stork. It's an herb with a stork's seeds. And so that's where we got the common name. I've never heard of before, is a pelargonic acid. But I'm so glad we have the I can't even say it, nonanoic acid. And finally, again, we're back with 10 again. We're back with goats. So again, we have goats in the root, capric acid. I'd rather know by decanoic. There are 3 roots that all mean goat in all these, and I'm glad I don't have to keep those straight because we use the IUPAC. So let's see what's going on here. We have substituted acids. The IUPAC is the chain numbering with the carboxyl carbon atoms. Substituents are then located in the usual way. Remember what I said when we had this, like here, this is always at the end. If it's always at the end, it's always going to number that 1, 2, whatever. So this will always be my first carbon, numbering that way because it takes the priority over really anything. If you're going to use the common name, the substituent located with Greek letters beginning with the alpha carbon. The alpha carbon here is a different carbon than the one we were talking about earlier with the elimination carbons. And it's the idea that if this is always the first carbon, then they said, okay, the common name will make the second carbon the alpha carbon, believe it or not. And then beta, and then gamma, and yada, yada, yada. Thank goodness we don't really use those. So let's go see what we're going to do up here. So here, by the way, I will put the IUPAC name first, and then the common name. And so first one, if this is 1, 2, 3, I would name it 2-bromo propionic acid. 2-bromo propanoic acid. That's usually the common name, wasn't I? And then over here for the common name, see how I couldn't type in the alpha there. Alpha bromo propionic acid. So again, because this is always the first one, common name starts with alpha and beta and goes from there. So yikes. Then we have this over here. Notice we have a alkene group. So we have 1, 2, 3 again. And so we're going to call it propenoic acid. Why don't we number it? Well, this is number 1. Count your bonds. How many bonds does carbon have here? It has 1, 2, 3, 4. Can this right here ever be a double bond? The answer is no way, Jose. That's 5 bonds on that carbon, not 4, so it can't work. So in the case of 3 carbons, you're only going to have it on the second one. So they go, well, because we're forces, right? We don't have to number it. Anything beyond 3 carbons, you'll have to number where that double bond is. Common name for this one is acrylic acid. I don't know if you remember, but this would be the acryl functional group. We've seen it times before, but again, it's a common name, not the IUPAC name. These other ones get pretty messy for the common. I don't think it's a problem at all for the IUPAC. Again, we got to number it. And notice how I numbered the carbon on the carboxylic acids, 1 as always. So the only thing we have to do here is number that. So it's 3-hydroxy butanoic acid. And I have it actually down here. Now, again, common is kind of a funky way. We kind of erase this. So once again, if this carbon is left alone, they number that one alpha, and this is beta. So look at the common name is beta hydrox butyric acid. Holy cow. So for me, I don't know about you, I'm really, really glad we have the IUPAC system. Because if do not mix, let's agree to only use the IUPAC. But I did think the common name is kind of interesting. I'm going to quit right here, and I'm going to get to the next recording because I'm going to run out of time. So we'll stop. You can catch up, catch your breath, and look for the next